owner has died in the Santa or in any Raitu Bazaar,
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are Clarus. You are top on the Everest. Congratulations.
I want to be a leader.
Good afternoon everyone. Myself, I am K.Pranay kumar, studying first MPC in prestigious college Chilkur. Friends, today we are going to discuss about an important thing and which plays a crucial life in our daily life and which influence our life from our birth to our death. So friends, now I would like to ask you some questions by showing some images. You just think what is the phenomena involved in that. See here friends, in our surroundings we might have seen the current poles, cell towers, etc. and the wires which are connected between the 2 poles are connected very loosely. Do you know why friends? Friends, if the wires are connected very tightly in winter season they will break down, but why? What is happening in that? Think. And next one friends, you might have seen that while constructing road, they construct road by dividing it into sections and between the section they leave some gap. Do you know why friends? Friends, if you do not leave some gaps between the road and if you do not divide the road into sections, then the road will get cracks in summer season. But why? What is happening in that? See friends, this is high speed aircraft. Friends, the wings of the high speed aircraft are fixed very loosely because friends, it travels with the speed of nearly 3 times the speed of sound. While it traveling with that speed, its wings got expanded, but why they are expanding? Here friends, see the old man. See the old man. He is showing the. See the old man. He is showing the window panes. There are some cracks in the window panes, and in the upper picture also we can see the window pane which is having cracks. In summer season, if we attach window panes very tightly, then the window panes will definitely get crack. But why? Why it is happening? And friends, while decorating the window panes, we insert platinum strings inside them. Instead of platinum strings, we do not insert any type of metal inside them to decorate that. We use just platinum strings only. But why? Okay friends, when we go to railway tracks also, we might have observed the gaps between the railway tracks, and if we do not let the gaps between the railway tracks, then in the summer season the tracks will expand and the tracks will get deformed. This causes rail accidents. But why it is happening? Why it is happening friends? That means the main reason which is including in that is thermal expansion. That is thermal expansion. In summer season the railway tracks expand more due to the heat. So I think you might have got what we are going to discuss now, that is thermal expansion. So friends, when we listen the word thermal, what hits our mind the first? That is heat. So when we listen the word thermal, immediately the word heat comes to our mind, and when we listen the word expansion, what we will think? That is nothing but increase in area or volume of a particular substance, that is called expansion. Here thermal expansion means increase in the dimensions of a substance due to heat. So First, let us know about heat. Friends, like all energies, electrical energy, mechanical energy, whatever it may be, muscular energy, like all energies, heat is also a form of energy that transfers from hot body to cold body due to temperature difference. Okay, now friends, in this definition, temperature plays a crucial role. So, let us understand what is meant by temperature, and after that let us again recall this definition. Okay friends, here temperature, it is a degree of hotness or coldness. That means it determines how cold or how hot a body is. Friends, let us take two objects. Okay friends, if we take two objects, we can say how hot or how cold a body is by measuring the temperature only. If the temperature of the body is more, then we can say that it is very hot. If the temperature of the body is less, then we can say it is very cold. Then, so here we can understand that temperature determines whether the body is hot or cold. That means it determines the hotness or coldness of a body. So, let us again go to the definition of heat. Friends, here a form of energy that transfers from hot body to cold body due to temperature difference. That means heat is a form of energy. Friends, it transfers from hot body to cold body. Hot body means the body which is having more temperature is known as hot body. Cold body means the body which is having very less temperature is known as cold body. Due to temperature difference means, let us consider two bodies. Temperature difference means each body having various different amount of temperature. That means one body should be hotter than the another body. This is called temperature difference. If there is temperature difference between the two bodies, and when they are kept in the contact, the heat energy transfers from hot body to cold body. Okay friend, that is what we call heat. If the heat energy is more, then we can say it is very hot. If the heat energy is less, we can say it is very cold, and temperature determines how heat or how cold a body is. Okay friends, now let us know how the heat and temperature are measured. Heat is measured in joules. The SI unit of heat is joules. 1 joule is equal to energy required in lifting 1 Newton of 1 meter, and the CGS units of heat is calorie. 1 calorie is equal to 4.186 joules. Okay friends, these are the measuring units of heat. By these units we can measure heat energy. And next one is temperature measuring scales. Temperature is measured in 3 types of scales. They are Celsius, Kelvin and Fahrenheit. Friends, in Celsius scale we will have 100 divisions. The lowest fixing point is 0 degree Celsius and the upper fixing point is 100 degree Celsius. Whereas coming to the Kelvin, the lower fixing point is 270 degree Celsius and the upper fixing point is 370 degree Celsius. And when coming to the Fahrenheit, the lowest fixing point will be 32 degree Celsius and the upper fixing point will be 212 degree Celsius. In Celsius and Kelvin scales, we have 100 equal divisions, but when coming to the Fahrenheit scale, we have 180 divisions. Friends, commonly we use Celsius and Fahrenheit scales to measure the temperature, and this is the relation between those 3 scales. Here absolute zero means a body, if a body does not have any amount of heat energy in that, then it is said to be absolute zero. That means when we measure it in Kelvin, the temperature will be 0 degrees Kelvin. When we measure it in Celsius, then the temperature will be minus 273.15 degrees Celsius, and when we measure it in Fahrenheit, it will be minus 459.7 degrees Fahrenheit. Okay friends, now these are the 3 scientists who discovered these 3 scales. Friends, the first one is Gabriel Daniel Fahrenheit. The scale Fahrenheit was named after him. So, this is the picture of Fahrenheit. And the last one is Andreas Celsius. The scale Celsius was named after him. And the middle one is William Thomson, and he is also called as Lord Kelvin. So, after him only the Kelvin scale was named. Now, let us enter into our main topic, that is thermal expansion. Thermal expansion means change in dimensions of a body due to change in temperature. That means, if you take a body, if the temperature of the body changes, then instantly the the dimensions of the body also changes. So, temperature of the body determines the change in dimensions of a body. When the temperature changes, then automatically the dimension changes. Here friends, if the temperature increases in this, then they will expand. If the temperature decreases, then they will contract. So, when the material expands due to increase in temperature is known as thermal expansion. Okay friends, here let us see how the thermal expansion occurs. Friends, naturally the matter will be like this, and it contains some particles called as molecules. So friends, each of them have some amount of energy in them. Here we are heating that means we are supplying heat energy to that. When they gain heat energy, they won't be stable, they start vibrating here and there. Due to the vibration caused by the molecules or the particles in a matter, the thermal expansion occurs. So friends, how the thermal expansion occurs means, due to the vibration of particles due to change in temperature, the thermal expansion occurs. And let us see how many types of thermal expansions are there. As we are having three types of matter, one is solid, another one is liquid, and another one is gas. So, the thermal expansion occurs in these three cases. Let us see the first one, that is expansion of solids. Next one, expansion of liquids, and another one is expansion of gases. Now, let us go through in detail of this. So, friends, now let us go through expansion of solids. Expansion of solid means the increase in dimensions of a solid is known as expansion of solid. See here, you can see that this is a cuboid. So, friends, there is a cuboid. After heating it, the cuboid's dimensions got changed. That is nothing but expansion in the cuboid, that is expansion of solid. See friends, the factors that influence expansion of solid are type of solid. Friends, in our nature we have different types of solids. Different types of solid have different various types of properties. So, type of solid determines how much the solid will expand. So, and next one is temperature rise. Temperature rise means that the amount of temperature that has risen in the solid or that we have provided to the solid determines how much does it expand. And the length. Friends, here we are having two particles, two objects. Okay friends, here this is a small one and this is a big one, and this contains large amount of particles, whereas this contains small amount of particles. So, when they both got heated in equal temperature only, but as it is having more particles, the particles will vibrate more. Then due to that, the expansion in this will be more than this one. As it is having less particles now, so the particles vibrates less. If they vibrate more also, they can't move very long distance. So, the expansion will be less. So, length of the particular solid also determines the change in the thermal expansion. And in expansion of solids, we are having three types of expansions. One is linear expansion, another one is superficial expansion, or we can call it as area expansion, and another one is cubical expansion, or we can call it as volume expansion. In linear expansion, linear means one line, that is one dimension one. If the expansion occurs in one dimension, then it is called as linear expansion. Area expansion or superficial expansion. Area means two dimension one. If the expansion occurs in two dimensions, then it is said to be area expansion. And the cubical expansion or volume expansion. What is meant by volume? The space occupied by an object is known as volume. If the expansion occurs in the volume, or we can say that if the substance occupies more space on heating, then it is said to be cubical expansion or volume expansion. Okay friends, now let us discuss about these three. First one is linear expansion. Linear expansion, here we have taken a rod, here we can taken a metal rod or whatever it may be, which is having expansion property. So there we are heating the rod, then see what happens. See, you can observe that the metal rod's length is increasing, it is increasing in one dimension, that means it is in a linear. So it is called as linear expansion, means I told you before, the expansion which occurs in one direction or in one dimension is known as linear expansion. Here the rod is expanding in only one direction, so it is called as linear expansion. And see here, see LO, that is the original length. See, that is the original length of the solid, and after heating the change in length has got, that is delta L, and after heating the total length will be LT, that means total length. Friends, here to measure the delta L, that means how much it expanded, are we having formula? Yeah, we are having formula to measure how much linear expansion that occurred in a particular substance, that is this one. Delta L is equal to alpha into L naught into delta T. Here delta L means the change in the length is known as delta L is equal to alpha. Alpha means here friends, it is the coefficient of thermal expansion in case of linear expansion. Here friends, every substance have various types of properties now, so alpha will be different for various substance, and LO, that means it is the original length of the particular substance, and delta T means the temperature change that we bought in the substance is known as delta T. And friends, let us discuss about area expansion. Here we have taken a rectangular sheet, that here we are going to discuss about area expansion. See friends, I am heating the rectangular sheet. See what happens when I started heating that, the change in dimensions occurred. How many dimensions I have changed means 2 dimensions. Here the length and breadth both got changed. As the change in 2 dimensions occurred, so it is called as area expansion. If the expansion occurs in 2 dimensions, then it is called as area expansion. Friends, see here friends, that is the original length. See, on the rectangular sheet we can see the original length, and on the strips we can see the delta A, that means how much change that's got in area. And after heating, how the total volume, the total area is called AT, that means total area. As we are having formula to measure delta L, we are also having formula to measure delta A, that is this. It is similar to the linear expansion formula only, but here some values changes, that is delta A is equal to, that means delta A means change in area is equal to beta. Here beta, there in the case of linear expansion we use alpha, here we are using beta. Beta means that is the coefficient of thermal expansion of a particular solid in case of area expansion, and A naught, that means the original area, and into delta T, that means how much temperature change that we bought in the object is known as delta T. By this we can determine how much area got changed in the object. And let us discuss about volume expansion. Volume expansion, here we are having a cuboid, it is a 3-dimensional object. As I said you, volume means the space occupied by a volume the space occupied by a body is known as volume, isn't it friends? If the expansion occurs, then the space occupied by the body increases, that is known as volume expansion. Here I am heating the cuboid, then see what happens. See, the dimensions of the cuboid are changing, the change is occurring in 3 dimensions, the expansion is occurring in 3 dimensions, so it is called as volume expansion. Friends, see, the middle one is VO, that means the original volume, and after heating we got some change in the volume, that is delta V, and after heating the total volume will be Vt, that means total volume. Here like area expansion and linear expansion, we are having formula for volume expansion also. To determine how much change that got in volume, we can use this formula. Delta V is equal to, delta V means change in volume, is equal to gamma into V naught plus, sorry, V naught into delta T. Gamma, here gamma is coefficient of thermal expansion of a particular solid. In case of volume expansion is known as gamma. And next one is VO, that means original volume, and another one Vt, that means the change in temperature that we bought in the substance is known as Vt. And friends, till now we have discussed about the expansion of solids. Now let us enter into expansion of liquids. See here friends, in the first case you can see that we have taken some amount of liquid in a container, and the temperature of the liquid is 70 degrees Celsius, and in the second case we heated that liquid. When we heated that, the temperature rises from 70 degrees to 140 degrees. When the temperature rises, I told you the moment of the particles in the substance increases. Due to that, the thermal expansion occurs. Here, as the temperature increases from 70 degrees to 140 degrees, the change in thermal expansion, the change in the volume of the liquid occurred, and the volume of liquid increased from 20 ml to 30 ml. And here in the third case, we have provided more amount of heat energy to that, and the temperature raised from 140 degrees to 180 degrees. Here the thermal expansion will be more, so the liquid flown out from the container. This is called as expansion in liquids. If the expansion occurs in liquid, then it is known as expansion liquids. Friends, in solids we are having linear expansion and area expansion, cubic expansion. But in case of liquids, we will have only volume or cubical expansion, because solids have definite shape, but various liquids doesn't have definite shape. They take the shape of container, so they have definite volume. So the expansion occurs in volume only. So liquids have only cubical expansion. See friends, this is an example for expansion of liquids. Here this is a thermometer which is filled with alcohol. When some temperature is provided to the liquid, then the expansion occurs in the volume of the alcohol. This is the example for expansion of liquids. So friends, we are having another matter, that is gas. So now let us discuss about the expansion of gases. Okay friends, here expansion of gases. In this, what we can see, here we are having a hot air balloon with through some flame we are providing some amount of heat energy to that. Friends, I told you, when we provide heat energy to a substance, then due to the motion of particles in them, due to the vibration of particles in them, the matter will expand. Here we are providing heat energy to the gas. Then see how much does it change. See, a lot of expansion occurred in the gas. So gases expand a lot when heated. Let us see the relation between the expansion of these three. Friends, here see, if we take three matter which are having same amount, that means same volume, one is solid, another one is liquid, and another one is gas. Let us see solid expanded somewhat, okay, and when coming to the liquids, it expands 20 times of the solid, and when coming to the gases, they expand 30 times of the liquid. That means here friends, the expansion in the liquids will be greater than solids, and the expansion in gases will be greater than liquids. Friends, here you can see that solids will be very strong, as the molecules in the solid are bonded very tightly, whereas in liquids there will be some gaps between the molecules, And when coming to the gases, there will be no attraction or repulsion force between them. They move as they wish. So, as solids having more intermolecular force, they can't expand more, and liquids having only a few less amount of intermolecular force, so they expand more than the solids. When coming to the gases, they don't have intermolecular force, so they expand more than other two matters. And here friends, we have learnt about thermal expansion. Now let us see where it is applicable, where we use thermal expansion. Let us see applications of thermal expansion. Okay friends, applications of thermal expansion. We use thermal expansion in case of preparing bimetallic strip. What does this name suggest? Bimetallic strip, that means bi means two, metallic means metals, and the strip means a strip, that means a strip made by combining two metals is known as bimetallic strip. See the figure here. Here we are having a strip, and on the upper portion we are having metal 1, that is one type of metal, and in the lower portion we are having another metal, that is another type of metal. Here the strip is prepared by combining those two metals, so it is called as bimetallic strip. So friends, while preparing bimetallic strip, we must think about the coefficients of thermal expansion of the metals, as the difference between the coefficient of thermal expansion of those two metals will be more, then only the bimetallic strip will work perfectly. See friends, where we use this bimetallic strip, how it is helpful in our daily life. Friends, it is useful in preparing thermostats. Friends, thermostats means what? We use such thermostats in iron boxes, refrigerators, water heaters, electric cookers. The main thing which happens in all these items is, or when they got sufficient amount of heat energy, that means when they are raised to sufficient amount of temperature, then automatically they switches off. Why they switches off? What's happening in them? Let us see what's happening in them. Here friends, this is the bimetallic strip. Okay, on the upper portion we are having brass, and in the lower portion we are having steel, and the difference between the coefficients of those two will be very more. Okay, here when they are in normal temperature, or when they are normal, the strip will be straight, and when the strip got heated, as the brass is having more coefficient of thermal expansion, it want to occupy more space. As it can't expand in linear, it bends downwards, and when we cool that, here brass having more coefficient of thermal expansion, means it also have more coefficient of thermal contraction. When the strip got cooled, as brass is having more coefficient of thermal contraction, then the strip bends upwards. So this is how bimetallic strip works. Now let us see thermostat. I have said you before, that means when a machine gained sufficient amount of temperature, then automatically the machine will get switched off. Here friends, see, here we can see this is a circuit. Okay now friends, this is a heat generator, and we are having bimetallic strip. Okay friends, here we are having bimetallic strip, and this is the temperature reading. Friends, this is the connection between the positive and negative terminals. Friends, if the connection here breaks down, as open circuit doesn't pass electricity, the electricity won't be passed. See here friends, here the heat is generating by this heating coil. When heat reaches to this bimetallic strip, as the upper metal is having more coefficient of thermal expansion, it bends downwards, and when the lower metal is having more coefficient of thermal expansion, so it bends upwards. See here friends, the temperature is rising, the bimetallic strip is rising upwards. You can see clearly here, the bimetallic strip is rising upwards, and when it raised upwards, the connection got disconnected, then